Hi, and welcome to today's video where we'll be discussing the Mars Climate Orbiter incident and its implications for computer engineers in space technology. We'll explore the key findings, NASA's response, and the importance of embedded systems in space missions. So let's dive right in. What was the main focus of the report mentioned in the article? So, the report mainly focused on the factors that led to the loss of the Mars Climate Orbiter spacecraft. So they sent a spacecraft, but something went wrong. In the report, they detailed the key issues in the in this case and shown what was the response of NASA. So, what are the key issues, like I mentioned, that were identified in the case? So, they were eight key issues or eight key points that were identified as the cause of the incident. First, there is an insufficient consideration of the mission as a whole. So, they did not factor in lots of things and they did not consider the mission as a whole. They did not plan as a whole. They just plan individual parts. Second is the inconsistent communication and training within the project. The third, lack of complete verification of navigation software and computer models. They did not check the software and the models they've used for the mission. Number 4, errors in ground-based computer models for spacecraft thruster firings. So, the models used by the computer is very critical for any spacecraft mission. So, any errors in these models can lead to catastrophes that was shown in the report. Number 5, inadequate information provided to the navigation team about spacecraft orientation. So, the navigation team can only work with the information that they are provided. So, if this information is lacking, there can be severe implications. Number 6, failure to perform a final engine firing to adjust the spacecraft's path. Number 7, weaknesses in systems engineering and inadequate tracking of mission aspects. Number 8, informal communication channels among project engineering groups. So there is not a formal way for them to communicate each part of the mission, whether they are on time or whether they're lagging behind. There is no way for them to communicate effectively and formally. Next, how did NASA address these issues? So, the issues that I've outlined are very, you know, they're very preventable. If only have NASA's done these steps earlier. So, what did they do? First, they mobilized the expertise at the Jet Propulsion Laboratory to address the report's recommendations. So they've read the report and they called the Jet Propulsion Laboratory and they action on it. Number 2, a special attention given to the navigation and propulsion issues through an independent review. So most of the key issues that I've outlined are in the engine firing, in the navigation. So they made sure that special attention were given to these factors because it is very important that you have a solid navigation model or a solid navigation procedure and a solid propulsion testing when it comes to space missions. Number 3, the number 3 thing that the NASA did to address these issues were communicating recommendations to the team planning the Mars Polar Lander landing. So after this incident, they don't want to happen it again. They made sure that on the next mission, the Mars Polar Lander landing, they told the team what they have found out. Number 4, conducting fault tree analysis and daily teleconferences for technical progress evaluation. So, one issue that I've mentioned is a lack of the teams to communicate and plan as a whole. So, to combat this, they made daily teleconferences to check the progress every day, and they also they also is now conducting fault tree analysis. So number 5, they increased the availability of the deep space network for improved spacecraft communication. So the deep space network allows for them to allows for the base to communicate to the spacecraft more effectively and efficiently. Then next, they appoint a senior management leader and review work plans. They also conducted independent peer review of operational and contingency procedures, and they have made effective processes to prevent critical mistakes in future projects. So, what is the importance of this in embedded systems, and especially embedded systems in space? So, understanding embedded systems is crucial in space technology because out there, these systems are the ones performing the operations of the spacecraft and larger systems as a whole. They handle critical functions such as navigation, guidance, control, data processing, and communication. The failure of Mars Climate Orbiter was attributed to a software error in embedded navigation system, emphasizing the significance of embedded systems in ensuring accurate and reliable spacecraft operations. So, what lessons can us computer engineers learn from this case? The importance of thorough verification and validation processes is one. So, in our project, we must always verify and validate the processes that we do for each step of the project. Another one is the need for attention to unit conversions and consistency. The main problem of the navigation software was the units was being translated from English to metric. So even these small things in the software can lead to big dangers. Next is the value of robust systems engineering and communication. We as computer engineers must design systems as a whole and not only rely on our knowledge in electronics, and be all we must also allow ourselves to communicate more efficiently and effectively. The significance of peer review and independent expertise is also a lesson that we can take away from this. The mindset of continuous learning and improvement, as shown by NASA, where after the incident, they made sure that the lessons they have learned from this is transferred to the next mission. So, in summary, the report focused on the factors leading to the loss of the Mars Climate Orbiter spacecraft, including the issues stated above, the communication problems, software errors, and they address these issues by conducting re- mobilizing experts, conducting reviews, improving communication, and implementing peer review. As computer engineers can learn lessons regarding verification, unit conversions, systems engineering, peer review, and continuous improvement. So that's it for this video. I hope that you've learned, and I hope you've learned something, and I hope that we can be better engineers by learning from our mistakes. That's all. Thank you po.